All right. All right. Thanks everybody for coming out. Devin, you especially for doing this talk. And I could tell you, I could tell everyone the background about this talk. So we had posted that, we're doing this Women in Linux Summit, and I think about 4 weeks into it or something like that. I was like, hey, we're still having this summit, but guess what? We have no women that had submitted. No women had submitted a talk. I had started doing talks and I was like, well, I can do this talk at this hour. And then, Dion was like, I'll do a talk. So Devin stepped up to the plate and was like, you know what? I'm talking. Like, yeah, I'm submitting the talk. And then after that, it started like a chain reaction. And then next thing you know, we started having more women submit talks. I've talked to several women online and they were like, we were afraid to submit because we thought that we were going up against heavy hitters. So I say that to say thank you, Devin, for submitting your talk. That's first. Thank you, everyone, for showing up actually to even see what was going on. So, with that being said, I'm going to turn it over to you to talk about introducing DTrace and the ultimate DTrace tool.
Thank you very much. Let's see if I can get my camera on, working here. Let's see here. Let's see. Can I take over the presentation?
You sure
Let's see.
can.
How do I do that?
I just sent you a thing to take it over, and it should have popped up on your screen.
This session's.
Oh, did I send it to you by accident? Oh, okay. Hold on.
No worries.
There you go.
There we go. Cool. Excellent. Let me take you over to a blank space, and I'll get our presentation up.
Got you. And
Excellent.
I'm going on mute.
So today's talk is going to be on dwatch, which is a tool that I've been developing over 3.5 to 4 years now. And let me just get my slides up, which are all published on, if you go to freebsd.org/doc, which is a fork of FreeBSD for my own nefarious purposes. And I'm also a FreeBSD developer too. You can blame me for the bootloader menu and all sorts of stuff. So right now we're going to pull up our slides and we're going to talk about dwatch. But we can't really talk about dwatch unless we first understand what is DTrace, because dwatch actually builds upon DTrace and makes it easier to use, and I kind of feel puts it in more common hands. So let's see here, Control-Shift-F. Hopefully everybody can see that. Okay, here we go. See, maybe I can minimize the GoToMeeting. I think it's fine. Okay, so what is DTrace? DTrace is, if you've probably heard about it, is very powerful, but if you've never heard about it, well, the D is for dynamic and the trace is for tracing, and it's a framework that allows you to really plumb the kernel and the application layer so that you can find really whatever you're looking for to kind of like back up theories to prove or disprove certain theories that you may have about what's going on during problems. And you can do this in real time, and Sun Microsystems was very adamant about making sure you could actually use this on machines without much impact. And of course, they have a great mascot, which is their ponycorn. It's both a pony and a unicorn. Moving on, so what makes it kind of special is Adam Leventhal, one of the core creators that was in the beginning, said that some of the non-obvious choices that were born out of the core principles of the design are that we have its own language, which limits what you can do. a micro virtual machine, and along with that, a compiler of the D language that compiles into stuff that's then put in the kernel. And what you put in the kernel is stuff that has a conservative probe point selection to say, I want to fire when I see X. And we'll get into what that is. But first, a little bit of history on DTrace is it was released in 2003 by Solaris. And from there, you can see it got ported to many different operating systems. DTrace for Linux was born. And today we have it in about 4 or 5 different operating systems. It's pretty amazing, and it continues to expand today. And here we have a little graph I made, which is entirely my opinion, but I went to Wikipedia and Google and searched for basically a few things, which is inception of a project, notable milestones, releases of books, awards, and being ported to other operating systems. Those all make this graph. So we can see here as there's really no rhyme or reason to the height other than every time there's a notable milestone, I bump the graph up by 1. And when you do that, you see a picture that, while DTrace is quite robust and been around for a long time, percentage-wise, not too much longer than the other ones. And this graph does not show you all of the other tracers on Linux. And we could actually waste a whole talk on all the different tracers that Linux has. But I've only pulled out a couple here, which are quite important, and that is DTrace, SystemTap, and ftrace, put on the same timeline. One that's not listed here that's relatively new is the Enhanced Berkeley Packet Filter, eBPF, which, according to Brendan Gregg, who's the quintessential author of the book on DTrace, like literally DTrace the book, which is on this graph here, he says that eBPF may actually be the holy grail to where DTrace on Linux can actually be the front end to eBPF, which has the entire back end to be safe, usable in production, and performant. Moving on, so what on earth is DTrace? So it's something that builds upon DTrace that actually correlates process information with the ability to fire something when a particular interest happens, either in kernel or user land or in a module or whatever. I have my own mascot, and my spouse worked on this tirelessly, and we developed it. And so Peaches takes a magnifying glass and allows you to look at DTrace, and she's a little bit Sherlock-like. She gets to get down there and analyze everything and impress all her bosses with all of the solutions that she finds, either proving or disproving certain theories in minimal amount of time. So what are the basics of dwatch? Well, it generates the D language for you. So it's really an engine for generating the DTrace language, which then gets compiled by DTrace itself and then injected into the kernel to do your nefarious bidding. So it correlates desired data with process data. It's quintessentially the whole purpose, but you can actually customize its entire output so that when something fires, you don't have to display process information. You can display whatever you want, or it's really cool. It has a snippet engine, which allows you to just say, I want this variable from this function call every time this function gets hit by any process. And along with that, by default, either show an entire process tree for the person that's hitting that trigger, or just the process info for that one process that hit it. So if you wanted, you could actually, with just a simple -v flag to dwatch, you can have the process, parent process, grandparent process, and ancestor process all in one blow in a little tree view, which is nice. It has a more intelligent probe selection than DTrace itself. I spent years trying to see how others use DTrace, and one of the hurdles was often how to specify a probe which you want to fire on. And so I spent a long time developing some algorithms that allow me to have easier selection of those points of interest if they are in fact unique. And over 98% of probes in DTrace are uniquely qualified by a single word. So this has an algorithm which makes it completely easy, saying, oh, I want to watch VOP remove. Well, I can figure out that's a function. There's no modules or providers with that name. You must have meant the function. So I'm just going to go ahead and watch that function. And Plus, also, it has pseudo integration, so you don't have to worry about, oh, geez, every time I run dtrace, I have to run it as root. It will just say, oh, I'm not root, run myself as sudo. And there is a few things that are unique that really kind of make dtrace sing. dwatch will allow you to dump the unique providers, unique modules, unique functions, unique names, whereas dtrace-l, unlike dwatch-l, will give you a format that's not machine parsable, and it will not really let you query the particular function name or module that you're looking for. You have to give it a particular probe with colons in it in the format you see in the top, which is provider, module, function, name. It's a format that is really actually quite cool, because if you want any provider to fire on any module for the function X, you would put : X and another colon for any name. Now, anytime it sees any provider, or module, or name with that function name matching, it will actually pass on, trigger that code that you have written to fire. That's not unique to dwatch. This is modeled after dtrace, but it's a more liberal selection point, and these -lp, -lm, -lf, and -ln invocations can show you, oh, okay, I've got X number of names, X number of functions, X number of modules, and we'll see that in live demo later. And of course, the most must-have command that you just can't seem to do with any other dtrace-based program is watch all the things. And here we're just basically using the shortest possible probe point selector, which is : meaning anything and everything. I could have a number of colons, but colon is shorthand for any name, any function, any provider, anything. And -F says trace the function, coalesce by function. So it shows entering a function, leaving a function, entering a function, leaving a function. So you can follow what a program is doing, or group of programs, or the entire system as a whole, as is shown here. And we'll see that during the live demo as well. So now, in depth in live demo. So let's see here, we're going to escape from that. Go to an empty place. Yeah, here's good. Okay. I'm going to a FreeBSD box first. It happens to be FreeBSD 11.0 release P1 running on 64-bit hardware. dwatch is in user sbin. And it's installed by a package, which, slight detour, go to pkg.freibsd.org, and there's the package collections. So I actually pulled mine out of here. It comes from here, although the instructions say all you have to do is take this, plunk it into a file, and I've actually diverted it to an in-house mirror, but that's basically a copy of what's on the web page. And then you would just say package install FreeBSD/dwatch, and then you get dwatch. And this is on FreeBSD box. I still have to port it to other operating systems, and we'll see why that is, and why, even though dtrace has been ported to other platforms, dwatch is actually very operating specific, every operating system dependent, which is all about the kernel and the architecture of something called the td-proc structure, which will be during the in-depth. dwatch itself has quite a lengthy usage for the syntax, but this is actually no different than dtraces. There we go. So this is dtraces, and on top of dtrace is dwatches, and we will see how they differ. When you're using dtrace naked, most people start here. Okay, list all the probe points. I'm going to Control C that. ID is just a number that keeps incrementing, the provider, the module, the function, and the name. For the most simplest example, if I want some code that runs SR is sudo, but just to show that. Well, SR is also sudo, just trust me. So DTrace allows you to check for certain names, certain functions, and you can use patterns, certain modules. I think I've got Ruby in this box. Yes. And certain providers. Oh. DTrace provider. You can also use short names. If you tell DTrace, if you give it a hint as to what you're looking for, you can use a simple name. Just for fun. Now, dwatch improves upon this by not having to be told what it is. Just give it any probe. In this case, it found out that you really probably meant syscall FreeBSD exec.ve entry. If there's any ambiguity, you can tell which it is, and you can use the DTrace syntax, which is a fully qualified probe, in order to resolve any possible conflicts. And further, if you have to tell it a module versus a name versus a function, you can. So if I really needed to say, okay, that is the function exec.ve. This is a nice segue into what I'm actually doing. dwatch exec.ve will actually watch this system call, which runs every time a process gets fork exec. And here we actually have Chef running in the background with some other cron jobs, I believe. And bzip ran in the background from newsyslog was its parent. Now I'm just going to log in a second box. That's all from my bash profile. I say ls. I actually have an alias, and I actually run everything through lolcat, which is actually a Ruby program, and there's some awk magic involved. I can turn off my unicorns and rainbows. Just get regular old ls, and unaliased ls is just a straight up ls. As you can see, it's fun to watch programs being executed, but that only is so helpful. Here's all the functions you can actually watch on. And unlike DTrace, I can take more than just a pattern. I can actually take a regular expression. Okay, I'll revisit that later. Oh, -r regex. Dirt. Okay. Nothing begins with right. What about ends with right? There's some stuff that ends with right. Cool. So we're building upon DTrace's abilities by kind of adding more features that make it easier to interface with this massive complex beast. I mean, there's 64,588 pro points on this box. So you gotta have some tools to allow you to sift through all of that. There's a nice man page that we can go through and see everything. So now what if I wanted to say watch only processes running as wheel. Only processes get forked to wheel by wheel. So now we're watching the system call that we've watched before, which is for processes get fork exec, but now it's only going to be limited to processes owned by the group ID wheel, which is the supergroup on FreeBSD. It's kind of like, well, wheel on Linux, I believe. That just, yeah, okay. So anyway, that ls is not tracked, date's not tracked, top not tracked. And back to myself, nothing is tracked. Only the stuff that gets executed as GID 0, which is shown in every single process run. To make things really fun, let's just add a -v flag. Run bash. Let's take this off. Let's see. I think I changed that in one of the betas because there was a conflict. I worked very hard to make the flags of DTrace not conflict with the flags of dwatch, so that way I could teach good manners, and that way if you ever get beyond using dwatch as a shim to do your bidding, you can use DTrace and your fingers won't fight you. And dwatch tree -R. Yeah, so when you develop a program over 3.5 to 4 years, yeah, your fingers fight you. You're like, hey, this was -v in the beginning. Okay. There we go. Going back to my other command. Not going to run, not going to catch that. Top, ls, date. So each one of these shows, top, started by the bash, which has GID, which is started by SR, which is predate sudo, stands for single root, which is started by the bash running as GID, UID GID 604, which is me. And then there's the top line, just for fun. Okay, so this is all cool watching processes run, but we can do so much more. I'll just zero in on this section here, called profiles. Gets its own section in the man page, which talks about little snippets that have been saved off to do more interesting things. -Q will list the existing profiles, which are actually in user libexec dwatch. But we also support loading them from ports as packages or third-party installations from user local libexec dwatch. And here I've made one specific for another FreeBSD developer, and I'll show you that later. But for now, we're going to look at processes being sent certain signals through the kill command. So I've got a module for kill where profiles look like this. This is a very simple profile. It's written in shell script, and here we're defining a default probe of syscall : profile. This profile is kill. So syscall : kill : entry. So when we enter kill, print this information. And this information gets printed after the process accounting information, so you actually don't have to worry about that. So in the development of going down a rabbit hole to find out if a theory is correct or not, you can develop a very small snippet, and you can actually pass these on the command line with a command line flag as well. You don't have to create a file. And it can help you extract the information that you need, like here, which is the PID and the signal that's being sent, and of course the probe function that actually fired. And here is a nice example of the DTrace language and how it sings. And we set a default here because it's dwatch's modus operandi to allow you to override that probe selection to provide the ability to apply a profile to another probe. When we get to the VFS, the virtual file system later, we're going to see how that really plays in. Okay, so we're going to dwatch kill. Okay, so now we're watching syscall kill entry. I do something stupid, which is kill -0, which is signal 0 is just really for checking if a process exists. And I'm going to kill the shell itself. So here, DTrace, the DTrace that dwatch generated, fed me the date and time that the kill happened, the UID, the GID, the name of the process, and the full command line of the process, and the PID. 35499 was sent signal 0. Now, if I enable the profile, which I apparently forgot to change something, kill does not match any probes. Some bugs to fix after this talk. Okay, let's see what we did wrong. I'm just going to fix this real quick. I'm pretty sure it's get ops. Process flag. That's right. Okay. There we go. Okay, sorry, just had to fix that real quick. Now when I send signal 0 to my process, it tells me PID 35499 was sent signal 0 by this process, which a little bit more info, that's because kill is a shell built in. Now, quite interestingly, what if I use the non-built-in? Now it's showing kill of that PID sent the process, my bash, that process, a signal 0. Just for fun. Signal 1, which is harmless if you don't care about your connection. Okay. If you wanted to correct this programmatically or get them in a single line, you can do that. So when I was helping another FreeBSD developer, he asked me, do you think it's possible to write something that automatically snapshots the ZFS file system whenever it reaches a certain amount of space rather than trying to snapshot it on a time basis? Rather than So that way we have snapshots that are limited to a certain amount of time, which makes it easier to transfer them in incrementals. Quite a heady topic. So I wanted to explore this possibility. To refresh my memory, because it was a while ago, my snippet is stored over here, so I don't actually have to think about it. I could just run it with -X, but I want to see what's inside it. I can change the pragmas. Here I need 16 megs, and I only want to cycle once per second. That's 1 hertz. Default probe is function boundary trace is the provider, ZFS is the module, and dnode will use space is the function, and we want to fire on entry. So when we do that, we have an int in the global space. So these profiles allow you to put together a script, and we'll see how these actually get coalesced into the DTrace generated by dwatch. So we have an int that we need. On startup, we're going to initialize it to 0. And when the probe fires, we're going to say bytes is equal to arg1. That's only executed once. For each time it runs, we're going to print arg1. So here we can actually dump the value that's being passed to dnode will use space, which is actually a ZFS VFS function for, well, I don't know if it's VFS, but it's the ZFS function for determining, hey, I need to write something. How much space will it use? And a dnode is the, like a vnode, if you're familiar with FreeBSD. It's the, it can represent an inode and other things. So what we're going to look at is how I actually developed that module to begin with, which is first I started with looking at all the things that happen with ZFS. So let's see here. LP, LM, ZFS. So here is all of the functions in the ZFS module, and we have 2 different providers, function boundary trace and SDT, which I'm not familiar with. And so we can look at all these ZIO functions or ZFS control functions or BDEV functions. I actually went down into the kernel and determined which one would be a good fit and then went from there. But you don't have to. You can do a survey, which is one of my favorite things to do with dwatch. Is so we just want to watch everything in the ZFS module. And instead of getting the process info after the colon, I want function info. And there's way too many things firing. Some of those, the white text that you saw go by really fast is standard error output. Standard out output goes through lolcat, so we can tell the difference. And here we can see how we traverse. There's no really special function for the arrows other than if it's an entry name or start name, then or begin, any one of those 3, it's a forward arrow, and if it's a return, end, or stop, then it's a less than. It's important to know not every function has both a return and an entry. The majority of the ones that have an entry have a return, but some do not have a return. So here, with this survey of what's going on in the ZFS space, we could look for that dnode stuff with a very cute awk post processor, which takes regex. So if I believe it's -Z, let's double check. Yeah, -Z regex, and it's all described in the man page. -Z regex only show processes matching awk regular expression, and the -Z is actually applied to the entire block. So even if you had the tree on, it would match on anything in the tree and using regular expressions. So here we're going to look for just any more dnode. I want to match on dnode in ZFS. Too many probes firing at once. And then we get into a circular loop where the firing of the probe causes the firing of the probe. So DTrace is robust enough to know performantly and safely do not cause an impact to the system. Drop packets, drop events if you need to on the floor. And if invalid addresses are not fatal. Let's see here. For making these things on the fly, I'll take a very simple one. So say, for example, fgmod at. Add as a multi-liner. I'll just start off with kill. Okay. So if I didn't know what I wanted to print, but I knew by the man page for the C library call, or whatever it is I'm working on, like for the dnode one, I actually had to go in the kernel and look at its arguments. I can see this is a pid tpid and intsig, but if I didn't have that module already to just xkill, I could say, yeah, -e code. -e print f %, we'll call I, not D, whatever. We don't print a \n, that's automatically done by dwatch. arg0, let's do arg1. That's it. And then fire on kill. Oh, caught one right there. Vim sent signal 18 to something. I'm going to end my session, but it doesn't matter. Signal 1. I don't know what the signal 19 is about, but if I wanted to know, well, that's on the FreeBSD box. So kill-l was 19. Interesting. Some child relationships. Okay. So any system you can kind of tease apart step by step, and if you don't know what you need to trace, dwatch is wonderful because you can have a global view, a global spec. Unlike, like, say, programs like DTrace, where you have to know the PID of what you want to trace or the process name of what you want to trace, and no patterns allowed, no regex allowed, or you have to invoke the program through DTrace. DTrace, for people that don't know, is actually truss, which is like strace, but uses DTrace. So let's look underneath the hood real quick. -D for debug. -D allows me to see what it's generating. So if I actually had a script that generated an error, I could dump it, and not only do we have the ability to jump to a line number from the error, every one of the probe points is labeled with an ID, which will be visible in the error. So if you get an error inside of one of the probes, the error will say probe ID 8 or whatever, and you can just jump to ID 8, which this one doesn't have an ID 8, there's only one. And that's how it really works, is we're generating all that DTrace for you, which if you take a look at, you really want to, because the D language doesn't have recursion or loops. Some enhancements have been made to introduce if statements, but basically all you have is the ternary operator and assignments, and it's pretty sparse. So you need a higher level language like DTrace, dwatch. I wrote it in shells to be cross-platform compatible. You need something like that to, with all of the options, put together what you're looking for. Like, I want to search on a PID. I don't want to search on a PID. I want to use regex post-processing. I want to do any number of things that would require a slight modification of the DTrace generated, but not wholly different. It took me years in order to abstract out the commonalities of everything that I was doing across the board, both at work and for play. Okay, so Let's see here. What are some of the more amazing things you can do? I'll go to the example section and we'll just step through those. Somebody recently asked me, I need to figure out what's happening when my box hangs. I'm like, yeah, how are we going to do that? If your box is hung, how can I tell you to run a program that will tell you anything? So we can run this in the background, actually, on CPU, and we can watch what's entering the CPU when it enters it. And then we know what's the last thing on the CPU. We can also see, right there, interrupts and rates, stuff like that. We could see what's entering the wait status. So dwatch-l from the sched a provider, can't remember. Yes, sched's the provider. The scheduler has change priority, DQ, NQ, len priority, load change, off CPU, on CPU, preempt, remain CPU. So preempt is actually probably a good one to watch if you were trying to find some process that's not responding, giving you a beach ball. Like when I port this to Mac OS X, I'll probably be using that to watch beach balls and like, who just got preempted? And so that's really fun. 1Q is just listing one at a time the module profiles available. -d-fsync will show you the script that's generated by wanting to probe on fsync, but not run it. Let's see here. -e is if you are really down in the nitty-gritty working on something very hard and you can't seem to get DTrace to run it, you keep getting compilation errors, you can actually pass the -e flag on to DTrace's -e, which has the same exact function, which is to not run it, but compile it and exit after compiling. So there's a great relationship between these two programs. So if you like me, yeah, I went through with a fine-tooth comb with multiple operating systems, making sure I didn't stomp on any flag. And if I did, then it had the same exact use as DTrace. Like we share E, we share little l is shared, m shared, n shared, p key, capital P is shared. -f read. Watch the function read. And since I'm talking on the SSH, all those prints are causing reads. Good stuff. Cyclical. -f colon is the master one to watch everything. Watch it all. Gory details. Everything the operating system is doing. Kernel and userland. Watch all the syscalls. That right there is an example of the intelligent probe matching. Syscall is actually both a provider and a function. And so it knows that since there is more unique probe points with the provider syscall, that it's probably what you meant instead of the one function with the name syscall, which is very nice. We've already seen -g wheel exec ve. You can use numbers. You can actually use a regex. Here's a or sign in regex. You can say, I want to trace jails. So if you have a jail running, like jail 1, jail 2, you say, all right, dwatch-j jail 1. All the functions of all the things. Sendmail is running. Oh, fun. Inside that jail. JSRJ exec, jail1, psax. Yeah, it's cranky. I don't think it has PS. I don't know, whatever. It's very interesting jail. And watch all the processes being forked inside a jail. Might be actually useful for Docker. My next project is actually to get Docker working on FreeBSD. We're meeting at Microsoft with some other people and going to do a hackathon on it. Let's see here. There we go. like nothing's really getting it, but now when I go jump in the jail, things inside the jail. Okay, so that, yeah, PS is broken inside the jail. Yeah. But you see, we catch the execing inside the jail and nothing outside the jail. Watch a whole mess of Ruby, watch syscalls, traversing daemon, processes with daemon in their name. Let's see here. List functions matching read. List functions matching read as a regex. List providers. Use a module, aka profile, for VOP remove. And that is where we get into... Oh, that is where we get into the common bits, which is ls-l. The logic that's used to parse what vnode is being operated on by a VFS function is the same for VOP lookup, make dir, make nod, and remove. They're all the same. rmdir, they're all the same. VOP rename is completely different. VOP symlink is definitely different. But VOP create, that logic is handled for multiple ones. So here, if we say dwatch -x VOP remove, now I can watch all of the files getting unlinked from the file system, any file system, in real time. Okay, so Vim just unlinked some temporary files. Touch abc foo rm-f $8. And that was done by RM. There's the PID of RM running as there. This is just too tempting. As a forensics, it's so much more interesting with a process tree. That RM was spawned by bash, was spawned by bash, was spawned by bash. And that's only because I have some my unicorns and rainbows on. Touch.
Oh shit.
RM.
Devin, we got about 3 minutes.
Okay. All right, so wrapping up, go back to my presentation, preview, which was somewhere, or not. Okay, so we're just gonna go to downloads. There we go, Shift F. All right. So Q&A, and then a big special thanks to everybody that helped make it possible, which is actually my spouse who drew Peaches, the dwatch ponycorn, the FreeBSD community, for all the reviews and feedback over the past 3.5 years. You guys all on the talk for, well, sitting there and being patient and watching everything, and so many more I have to be thankful for. But for any remaining minute we have, is there any Q&A I can handle?
Actually, there is, and you also have booth time. I don't know if you're able to get
excellent.
to your booth. So you have your own little personal booth, but there were some questions, and I'm scrolling back up for those questions. One was, would DTrace be ported over to Linux? And I remember you mentioning that at some point you were working with someone about that, so I'll let you take that question.
Yes, we are. The DTrace for Linux project was started back, is one of the solutions that's being touted, and that was started back in about 2008. If I can go to the live documents. Just 1 second. Slides, graphs, timeline. April 2008. But the real thing that you want to look at here is Linux version 4.9 RC1 in October 2016 that was released. If you're running that kernel, you have the ability to do eBPF backend, which is, I think, going to really allow the DTrace port to fly.
And
So you might
then
have to wait a little bit longer.
And then I think the next question, or I guess a thought was, I know Watson was mentioning something about using dtrace or dwatch for containers.
Yes, jails are containers that are native to FreeBSD. Ported to Linux, I don't see why not. Why you couldn't trace an LXC container with it, and therefore Docker, because Docker is LXC.
And I think those were the two major ones I saw, and the other ones about the locale cat that me and you went over because everybody was like, "Oh, it's so pretty." So,
I will
but
give you a sneak peek on that. So my home directory is in CVS, and it has all of the lolcat integration and 181 revisions. I forget where I'm at now, but it's not easy. It's several hundreds of lines of code, and that's because it has to hook into Bash's secret debug hook, and it fires before every command and actually sets up a function of the name you just tried to run and runs the original while being piped out while preserving the exit status. So you're truly not supposed to know that it's happening in the behind the scenes, but as we saw with dwatch gives up the ghost. With just watching exec.ve, you can see. So dwatch exec.ve, watch what's going on. In fact, I'll turn on parents. Okay. So without lolcat, a date is a date. With lolcat integration turned on, a date is not just a date. A date is a bash subshell piped into lolcat, then post-processed with awk to collect the exit status of the original program and then exit accordingly to preserve the exit status. So it's quite in depth. P, whatever. That's lolcat. Yeah, it's fun.
well, Devin, thank you, and thank you for everybody for watching. Devin has booth time. Uh, you, I know it was a lot. I recorded it, so you got a chance to actually go back and review this. I thought the talk was cool. And it's very informative for a lot of reasons, just to see what's going on in the background and step by step actually. So you can meet Devin in Devin's booth. We're gonna get ready for Michael Jenkins. And we'll see you at Michael Jenkins' talk and catch Devin in Devin's booth.
Thank you so much.
Thank you.
I was trying to get my pony on the screen. There you go.